So today what we'd like to do is we're gonna look a bit more into matrix. Now, before we begin, what we want to do is this. I'm gonna introduce you to one thing here, 2 by 2 matrix. Let us say we have 2, 5, 1, 6. I just randomly made this one. And I'm gonna multiply this one by 1, 0, 0, 1. When you multiply these two matrices, what would you end up getting? Okay, so you gotta first multiply these two by these two correspondingly. Then we get 2 times 1, which we get 2, and then 5 times 0 equals 0, so we have 2. How about the second one? We're gonna multiply 2, 5 by 0, 5, so then what do we end up getting? 2 times 0 equals 0, 5 times 1 is 5, okay. And then next, with these two, so when you multiply these two, we get 1 times 1 is 1, and 6 times 0 equals 0, so here we get. Lastly, we have 1, 6 is multiplied by 0, 1, that means 1 times 0 is what? 0, and then 6 times 1 is 6. So we get this one. Interestingly, what ends up happening is, this was the original matrix. When we multiply by this matrix, we get the same matrix back. That's right. This is called identity matrix. Identity matrix under multiplication. Meaning when you multiply this matrix to another matrix with the same dimension, of course, you're going to get yourself back. So in fact, identity matrix is a diagonal here becomes 1 and all the other elements become 0. So for example, if I have 3 by 3, identity matrix would have been 1, 0, 0, 0, 1, 0, and 0, 0, 1 would have been the identity matrix. If you're curious, then you can multiply this 3 by 3 matrix to any other 3 by 3 matrix, and you'll be able to realize that you're going to get yourself back. Now, but why am I mentioning about the identity matrix? Because the concept of which we're going to talk about is the inverse. Inverse of a matrix. What's the meaning of the word inverse in mathematics? Inverse is something that produces identity. In fact, if you remember, when we are dealing with addition, so if I have 3 plus what value gets you? Additive identity, which is equal to 0. You see, this is identity element. And then how about 3 times what? Get you identity under multiplication was 1. You know, and then what if I have a function f of x? I'm going to compose that with something else, h of x. But I have to get my identity function, which is equal to x. So all these things are different, but they're all identities. And then the other component becomes inverses. So inverses are the ones that produce identity. So my question to you is this then today. I have a function, let us say, not function, matrix, 2, 5, 1, 3. Let us say I have something like this one. What can I multiply so that it becomes identity? 1, 0, 0, 1. I don't know what that is. I'm going to call this one as x, y, z, w. Maybe I'll just give you a little bit of time for you to think about this one. Can you find a matrix where when you multiply by this matrix, it would become the identity matrix? So we can call this one as inverse of this matrix. All right. So I'm sure you thought about it a little bit. I don't know what the values are, so let's try to make a few equations. Maybe, hopefully, they will set us. They'll help us to find that. So first, I'm going to multiply 2, 5, and then x, z. So we get 2x plus 5z must be equal to the first value, which is equal to 1. And next, 2y plus 5w has to be equal to 0. Next, 1 and 1, 3 will be multiplied by xz. So we have x plus 3z has to be equal to 0. Lastly, y plus 3w has to be equal to 1. Oh, then we have two sets of system of equations, so we can figure out an x and z value. Here I realize that I can multiply this one by -2. Then we get to realize first one was what? This one becomes -2x minus 6z equal to 0. And I'm going to write that original first equation, 2x plus 5z equals 1. Then you get to realize that when you add them up, -z equals 1. So z must be equal to -1. If z is equal to -1, what do you realize about x value? You can easily see that x is equal to -3z, so which becomes what? 3. So x must be equal to 3. So we found those two values. How about y and w? I'm going to do the same. I'm going to multiply by -2 on the second equation. So we get -2 y minus 6w equals -2. And then first one I'm going to write them as it is, plus 5w equal to 0. So when I add them up, these two cancels away. -w equals -2. So w equals 2. If w is equal to 2, I can use the first equation, so we get 2y plus 10 equals 0, so y becomes -5. So I think we found all four values. Then what should be my inverse of 2, 5, 1, 3? X was equal to 3. Now, how about y value? Y value was -5, and then z value was -1, and w value was equal to 2. So when you compare this matrix to this one, they look very similar, except that they changed a few locations and then negated and stuff like that. But is this coincidence? I'm not sure. Let's try to look at another example. So this time what I'm going to do is I'm going to assume that my first matrix is A, B, C, D. And I want to multiply this one by X, Y, Z, W. And produce identity matrix 1, 0, 0, 1. So as you can see here, this second matrix must be the inverse of the first one. Then how are we going to get that? I'm going to set up the two equations just like before. AB is multiplied to XZ, so we have AX plus BZ equal to 1. And then same thing, CD is multiplied to XZ, so we have C X plus DZ equal to 0. How am I going to solve this one? I'm going to multiply this one by C. I'm going to multiply this one by negative A. How about that? Then we get AC X plus BCZ equals C. Now, negative ACX minus ADZ equal to 0. So I can add them up, and these two cancels away. So we get BC minus AD Z equal to C. Then what is Z equal to? Okay, that's equal to C over BC minus AD. Now, for later on, you will understand why, but I'm going to just multiply top and bottom by -1, so that I would like to have AD first before BC. So then this is equal to negative C AD minus BC. They're essentially the same one way or the other. Now, if C is this way, then how would you find out what X is equal to? I can put that in to, I guess, this equation. So I realize that C X plus dz, z is equal to this way, so negative c over AD minus BC equal to 0. So I can divide by c. Then what x is equal to is d over AD minus BC. They have the same denominator. So well, we found two values one way or the other. Let's look at the next one. How about YW? So we're going to do the same kind of calculation here. A y plus b w is equal to 0, I believe. Now cy and then dw is equal to 1. Same way as before, I'm going to multiply this one by c. I'm going to multiply this one by negative a. Then what do we end up getting? So we get ACY plus BCW is equal to 0. Here, negative ACY minus ADW is equal to negative A. So when I add them up together, these two cancels away. You get to figure out that W can be factored. So we have BC minus AD equals negative A. When I divide by that, we get W equals negative A over BC minus AD. But why don't I multiply top and bottom by negative 1? So we get A over BC minus AD. I mean, I should get the other one because I multiply top and bottom by negative 1. So I should be getting AD minus BC. All right. Then how about y? Because we found what w was. So I'm going to use the first equation. So ay plus b times w, which is a over ad minus bc equals to 0. And you can see that a's can cancel away. So we get y must be equal to negative b over ad minus bc. So in fact, then you get to see that, hey, x, y, z, w. This can be rewritten as x was, I believe, d. So we have d ab minus bc. AD minus BC. That was the x value. How about y value? Y value was negative b. So negative b over AD minus BC. How about z? Z was negative c. So negative c over AD minus BC. Lastly, w was a. So a over AD minus BC. You know, you can see that AD, the denominator repeats all over the place. So why don't I just factor that out? Because it's a scalar value, 1 over AD minus BC, and then we have D minus B minus C A. In fact, you can see that this, what we just found was the inverse of ABCD. So if you want to, you can memorize that 2 by 2 matrix. The inverse of that becomes this way. So it's not that bad. Now, but this is only one way for us to find the inverse of a function, inverse of a matrix. We could find the inverse of a matrix on 3 by 3 as well, but it becomes a little bit more complicated. Now, find the same inverse of the same matrix 2. I think it was 2, 5, 1, 3. But using the row operation. So in order for us to do that, I'm going to augment it with another matrix, identity matrix, in fact. So we have 2, 5, 1, 3, and then 1, 0, 0, 1. So you can see that this will be my augmented matrix, which is identity matrix here. And what I'm going to do is by the row operation, I'm going to make my left side into the identity matrix. Hence, making my, and then whatever I'm getting as a result on my right side, that becomes my inverse of a matrix. So then first what I'm going to do is I'm going to multiply the bottom row by -2. Then I get -2, -6, 0, and -2. So what I'm going to do is I'm going to now add up those two. So first row is the same, 2, 5, 1, 0. Second row is, I'm going to multiply them, I get 0, -1, and then 1 and -2. But I want to have identity matrix, so that means I'm going to multiply the second row by -1, so I get 2, 5, 1, 0. So 1, 0, 1, -1, 2. Now, let's look at the first row. I want to get rid of 5. How am I going to do that? Multiply this one by -5, and then add them to the first row. So I get 0, -5, and then 5, and then -10. So when I add this one to the first row, I get 2, 0, and then 1 plus 5 becomes 6, then -10 plus 0 becomes -10, while the bottom row stays as it is. Now, when I divide the top row by 2 so that I can have identity matrix, 1, 0, 3, -5, 0, 1, -1, 2. And if you remember very first question, -5, 3, -5, -1, 2 was the inverse of our first matrix, which was right over here. Now, so we now know the formula of how to do it, or you can use the row operation to find it. Row operation, in fact, is very manageable, even if it's a 3 by 3, even though it's a little bit annoying to finish the long question, but you can get the answer. But as a closing, what I'm going to do is, yes, we did end up getting 2, 5, inverse of 2, 5, 1, 3 was in fact 3, -5, -1, and 2, but we'll try to get this answer through formula. How about that? If I have to remind you the formula, A, B, C, D, inverse of this matrix was first 1 over the AD minus BC. And then what happens to the other one? A and D switches the location, D and A, but B and C will be simply negated. So then let's try to see what we end up getting. 2, 5, 1, 3 was our original matrix. It's going to be AD, which is 6 minus BC, which is equal to 5. Oh, that's equal to 1. That's a bit easy. And then swap the diagonal one, which is 3 and 2. The other 2 has to be negated, -5 and -1. And then when you multiply, this one is equal to 1 multiplied by that one, our answer should be simply 3, -5, -1, and 2. And you can see that this was in fact same matrix as our previous way. So we talked about the importance of getting not important, how we getting the inverse of a matrix. But let me try to share with you one application here. One of the applications which we can do is, once again, I'll use the system of equation. So imagine if I have 2x minus 3y is equal to 1, and then 5x plus y is equal to 11. And I want to find out the value of x and y. We know how to express this one, because this one was in fact 2, -3, 5, and 1. And then xy for the variable, and then our result was 1 and 11. But the thing is, okay, what I want to have is x and y by itself. How can I simply have x and y by itself? Then I need to get rid of the first coefficient matrix here. But how would you be able to get rid of this one? Oh, if you can find the inverse of this matrix and multiply that on my left side, obviously I have to do the same thing on my right side as well, then I should be able to get rid of this one and then get this one alone. So what is the inverse of the coefficient matrix? Let's figure that out on the side. 2, -3, 5, and 1. What is the inverse of it? So first I need to get the scalar factor. So 2 times 1, which is 2, minus these two, which we get. This is 15, so plus 15. So we get total 19. And then what we end up getting is these two we have to swap the order, 1 and 2. The other two we have to negate it. So we get 3, this one becomes -5. So in other words, 1 over 19, 1, 3, -5, 2. This is the matrix that I need to multiply here, left and then right. So let's try to see what we end up getting. So then, if you multiply this one by the matrix, so what I'm actually writing down here is this. Let me put this one over here. What I'm trying to do since this is a inverse matrix, I'm going to put this one over here in the front. And then same thing is being multiplied here as well. Then these two are supposed to cancel away, and then whatever remains should be my answer. Let's see if that works. Let us see if that works or not. So first, I'm going to push this one to the bottom. So let us multiply. Since this is scalar factor, we're just going to multiply this one at the end. So 1, 3 is multiplied by this one. So what do we end up getting? 1 times 2 is 2, and then 3 times 5 is what? 15. In fact, actually, this one's supposed to be 15. I think I made a silly mistake here, because 3 times 5 is 15. So this one becomes 17 rather, not 19. Same here as well. This one should be 17. Now let's multiply them. 1 times 2 equals 2, and then 3 times 5 is 15, so we end up getting 17. But don't forget we have 1 over 17 here. Second one is 1 is multiplied to -3, which is -3. 3 times 1 is what? 3. When you add them up, we get 0. Now here, these two, -5 multiplied, -5 times 2 is what? -10. 2 times 5 is what? Once again, we get 0. Lastly, -5 times -3 becomes 15, and 2 times 1 is 2, so we get 17. Oh, okay. And then we get x and then y. Let me try to continue to work on the left side here. I forgot here. This one was supposed to be 17 from my previous silly calculation mistake. So when I multiply these things out, then I get to realize that I get 1, 0, 0, 1. So when I multiply these two, 1, 0, 2, x, y, then I get x left. 0, 1 multiplied by xy is I'm left with y alone. So my left side is all good. Let's look at my right side. What is that equal to? 1 over 17 was still there. 1 and 3 is multiplied here. 1 times 1 is 1, and 3 times 11 is what? 33, so we get total 34. And negative 5 times 1 is negative 5, and 2 times 11 becomes 22. So 22 minus 5 becomes 17. So when you multiply those two things, we get to realize that we get 2, 1. Since that, as you can see, these are equivalent matrix, so x must be equal to 2 and y must be equal to 1. And in fact, if you had to plug in 2 and 1 into the original equation, they should work out correctly. So this is one simple example of how we can use inverse of a matrix to find the values of x and y. And with that one, I'm going to close up. See you later.